Did anyone ever ask you to factor something and this is the expression on your face? You just have no idea what multiplies to 12 and adds to 7, and you end up sitting there fiddling around with your calculator trying to guess for the longest time and just get so frustrated you end up tearing up your piece of paper or just crying in the corner. I don't want that to be you. Remember, good mental health. Let's give you a formula that will work every single time to get you those two numbers. So you're probably thinking, well, duh, 3 times 4 gives you 12, and those two add to 7. Why do I need to use this really complicated formula? Well, sometimes you're going to get numbers like in 1b, and they're going to be either very complicated or very big numbers, and you just don't want to have to factor those types of numbers. So I'm going to teach you how to use a quadratic formula today. Okay, and as you can see, it's the third method for finding your x-intercept. Now, in order to do it, you need to first have your equation in standard form. Okay, it's really simple. Your a are the numbers that go into your formula. Your b, that number goes into the formula here and here. And your c is the one that goes back there. So when I take a look at 1a, I notice that my a value in front of the x squared is 1. My b value is this number in front of the x, which is 7. And my c value is this number at the back, is 12. Okay, now notice that it does have to equal to 0. If you have things on the other side, definitely move them all over so that they're all together. Okay, so it has to be 0 on one side, because remember, you're looking for x-intercepts. So y is 0 at that time. All right, let's use a formula now. X equals to negative b, now remember my b is 7, plus or minus. Now the plus or minus gives us those two x-intercepts. It gives us our two answers. B squared minus 4 times our a, which is 1, and our c, which was 12. Okay, if your square root sign is too short, make sure that you extend it all the way. And that's all divided by 2, and then your a value, again, that's 1. All right, what we're going to do now is we're actually just going to simplify it. So negative 7 plus or minus, and underneath the square root sign, we're going to do some BEDMAS. Definitely do the exponents first. So that's 7 sevens is 49. Minus, and then we're going to do our multiplication. 4 times 1 times 12 gives me 48. All over 2 times 1 on the bottom, which is 2. All right, 49 minus 48 just gives me square root 1 over 2. And the square root of 1, well, that's pretty simple. Isn't that just 1? Negative 7 plus or minus 1 over 2. Okay, I'm going to move up just a bit. All right, here's where the two answers come in. So you got negative 7 plus 1 over 2, and your other answer is the negative 7 minus 1 over 2. And those give us negative 3 and negative 4. Now you're probably wondering, I don't get it. Didn't we just say that the two numbers that multiplied to 12 and added to 7 were 3 and 4? You're right. Well, those two numbers do multiply to the 12 and add to the 7, but those are the numbers that go here and here when we factor. And if you'll remember, if we're solving for the x-intercepts, they're actually the opposites of these numbers. And that's where we get the negative 3 and negative 4. Okay, let's try this again. So our a value for 1b is right there. Our b value is the negative 20. And our c value is the 50. Okay, so x equals negative, and then our b value, that's negative 20. So you're going to have a double negative right there. Plus or minus. Again, the b value squared. Minus 4 times your a, which is 2. And your c value, which is 50. all over 2 times your a. Okay, so a negative and negative make a positive, positive 20. Plus or minus, it's very important to put the negative 20 in brackets underneath the square root sign in the previous step, because if you have negative 20 without the brackets squared, you're going to get a negative 400. Okay, so negative 20 in brackets squared should give you a positive 400. Minus 4 times 2 times 50, I think that's also 400. All over 2 times 2, which gives me 4. Okay, so you're probably noticing that the 400 and the 400, those are going to cancel out and make 0. And the square root of 0, well, that's just 0. This is turning out to be a pretty easy answer, actually. Okay, and we're going to get our two answers, plus 0 over 4, or 20 minus 0 over 4. And wait, that gives us 5 or 5. Okay, so we get the two same answers in this case, instead of the two different answers in the previous case. All right, well, that's okay. Why don't we do the third one, and I'll kind of explain why I chose these three questions. Okay, so now I'm not going to use all of those different kind of colors. I'm hoping that you can follow me. X equals negative b, which is negative 2, plus or minus square root b squared minus 4 times a, which is 1, times c, all over 2a. Okay, negative and negative again makes a positive. Negative 2 squared is 4, minus 4 times 1 times 3 is 12, all over 2 times 1, which is just 2. Are you starting to see the problem here? This one is going to give you a negative root number over 2. Okay, so I'm getting this negative number underneath the root sign, and that's a major problem because we don't know how to take square roots of negative numbers. That's actually a complex number. So, I mean, we could just write our two answers, 2 plus root of negative 8 over 2, or 2 minus negative 8 over 2, but I mean, we can't really go any further because I don't know how to punch that into our calculator. So what I'm going to do is I'm just going to explain the three different cases that we just had. All right, in the first scenario, if I decide to draw this, x, y, negative 4 maybe is about here, negative 3 might be right about there. You have your two x-intercepts at negative 3 and negative 4. So when I draw this, your parabola actually cuts into the x-axis twice. In other words, you have two real roots. Another word for roots is your x-intercepts. Okay, so they use roots sometimes in upper levels. Two real roots means two regular numbered roots. Okay, in this case, the second one, you only have one real root because you got the same answer, 5 and 5. If that's your only x-intercept, well, that's probably the tip of the parabola then. You only touched once. In other words, you only have one real root. Or remember, one real x-intercept. Another way that people have written this in the past is two equal roots. Okay, so you can either say you have one real root, which is 5, or you can say you have two equal roots, which are 5 and 5. All right, and taking a look at the pattern, okay, so I had two roots, I had one root. Now this last one, obviously, since we can't figure out what the answers are, we have no roots. As in, it doesn't touch at all. It doesn't touch the x-axis. So in this case, we would say that we have no real roots, or since they're not real numbers, because these are complex numbers, we could also say another word for complex numbers are imaginary numbers. You have two imaginary, so unreal, roots. All right, so those are your three cases. They each tell you how to get your x-intercepts, and no more guessing. You actually can just use a quadratic formula every single time now. Okay, so you're very welcome.